All right, so quick recap. Module 3 was mostly about playing with equations. And the kinds of equations we played there graphically were lines. And so some important things there, we use different variables sometimes than y and x, depending on the situation, but we generally had a fixed number called m and another fixed number called b. So anybody remember what m is? Slope, and what's another phrase for slope? Rise or run, yeah, give me another one.
Rate of change.
Rate of change, yeah, so that's the big thing. So the m here is slope, and it represents what we call a constant rate of change. So once we establish the rate of change, it stays the same. That's what makes a line a line. If the rate of change changes, then we end up with a curve. Okay? Like, for example, if I were to jump off the roof, I won't do that, I promise. But would you agree my speed would change? If it didn't change, then I could jump off the roof like I jump off a desk. It wouldn't matter. But my speed's going to increase, right? And speed is a rate of change. So there's a lot of situations where the slope changes over time also. So then we get some kind of curve. And so that's what we're going to start jumping into next.
That's weird because you'd be going down, but if you do the slope, your slope would be going up because you do the speed, right?
Yeah, and the way we deal with that is we talk about negative speeds going down and positive speed going up. Yeah, so you get an increasingly negative speed is what happens, which is pretty cool. Do we get to look at that? I don't think that comes up in this unit, but I think we'll deal with it in 105, but maybe you take that. So in module 4, we're still going to play with equations, but here we're going to have variable rate of change. So variable rate of change means we're going to have things that curve when we plot them. Okay, so maybe we'll build a table in Excel, and when we plot those points in Excel, we'll see they curve. They don't line up anymore. Okay? And there's lots of different ways things can curve. There's a gazillion different kind of equations for that. We're going to focus on one type of equation. We're going to focus mostly on one type of equation called exponential. So we're going to have changing exponents this time. So that's the big thing that we're moving to. All right, so then we need to do this, we need a little bit of review back from module 2, which was ages ago. So in module 2, we played a lot with percentages. And a particular percent we're going to play a lot with this term is what's called an APR, which I think we talked about a little bit in 2. Does anybody remember what APR stands for? Something rate. Okay, we got the rate down. How about P? Percentage rate. Okay.
Average percent rate.
Not average, what is it?
Annual.
Yeah, APR stands for annual percentage rate. So anytime you deal with anything financial, whether it's a student loan or a credit card, they're always going to give you an APR, it's the annual percentage rate. So it's the amount of interest you pay over a given year. So maybe we have something like, and we'll call that R for short. So sometimes I'll write it as APR, sometimes I'll write it as R. But the big thing we got to remember there is that annual is involved. Rates always come with time periods. How long is that rate good for? So let's suppose we had a rate of 10%. Yeah, we'll get to that in just a minute, Emily. So again, this rate is an APR. But often, if it's a loan, whether it's a student loan or a car loan or a house loan or just any kind of loan, or maybe it's a credit card, do you just have to deal with that thing once a year? No, what's typical? Yeah, usually you have to have some kind of monthly transaction. So the question is, well, what do we do with monthly transactions? Okay, so let's suppose it's a credit card, right? And you buy something for $100. At the end of the month, what's going to happen? You get a bill, and you got to deal with that bill. Now, with most credit cards, you don't have to pay the whole thing. They give you this minimum payment you have to do. Okay? Otherwise, if you don't do that minimum payment, they charge you a penalty unless you made some special arrangements with them. So, how much interest? So let's suppose on the first day of the month you bought something for $100. The month has passed. They send you a bill. Are they going to expect you to pay 10% of $100? No?
Yeah.
Yeah? No? I guess some yeses and some no's. What's that, Aaron?
So isn't it at least?
Wait, say that again?
At least 10%?
No.
No,
Here-
it's 10% divided by 12.
Yeah, so the 10% is what they would charge you if the $100 was in there for a whole year. Only a month has gone by. They can't legally charge you 10% for a month because the whole year hasn't gone by. It's only part of the year. So what would happen here is the amount of interest, so the interest amount would be calculated by taking the $100 that you owe them, multiplying by the rate, 10%, which would be 0.1, and then multiplying by the amount of time that's gone by. And we looked at that a little bit in module 2.
What interest?
Yeah, that's my abbreviation for interest amount, INT. Interest amount. I ran out of room, I had to squeeze it in there. Okay. So this is what we call taking P, the principal of balance, times the rate, times the time. So the interest amount is your balance, times your rate, times your time that's gone by. If the whole year has gone by, T would be 1, and they have the right to charge you the full 10%. Otherwise, they basically calculate what's called a monthly rate. So if I just focus on this part right here, I get a monthly rate of that 10%, 0.1, divided by 12. And divided by 12 is a pain, so we're going to get this weird number that goes on for a while. But that's the monthly rate. So just in short here, if the APR is 10%, then let's call it MPR for monthly percentage rate. That would have to be 10% over 12, because there's 12 months in the year. They can even do a daily rate. And they actually do that. If you look at a credit card statement, they'll talk about your average daily balance. And that's how they charge interest on your average daily balance. So it'll matter whether there's 28 days in the month, or 30 days in the month, or 31 days in the month. Okay, but we're just going to simplify it and just say every month is 1/12. Otherwise, we have to do things like 28 out of 365, or 30 out of 365, which is just a payment. All right, questions on annual rate versus monthly rate. So that's going to be important throughout this unit. Another thing that's going to be important that we looked at a while ago is the idea of percent increase. So this is way back from module 2. I just want to refresh everybody on it, because I think this idea has probably collected a bunch of dust. So a percent increase is like owing money on your balance. It's like when you go and you have to pay tax on something. So like if you go to Washington, they have a sales tax of, I don't know, it's like 7% or 7.5%, something like that. That's on top of what you already owe. And so, or, let's see, we'll just stick with that. So let's suppose we're talking about sales tax as an example. And let's say the sales tax in a particular state is 8%. So you buy something for $100. So that's the cost of the item. Figure out what you're gonna have to pay. With or without a calculator. So remember, percent means out of 100. So 8% means 8 out of 100. So if I already have 100 there, I think I'm gonna have to pay another $8. So I'm gonna end up paying $108. Two ways to calculate that. One way is we have to pay $100 already, and then we have to add on the interest amount, which is gonna be $100 times the interest rate. So that gives me 100 plus 8, which is my 108 that I have to pay in the end. Does anybody remember the other way to think about this calculation, a percent increase, instead of doing it in 2 steps like that? Remember we talked about it?
Yeah.
Anybody recall?
108%.
Yeah, what instead we do is we just say, hey, I'm gonna end up always paying 108% of what I started with. And so an alternate calculation here would be to say, just take that whatever dollar amount, $100, $50, whatever, and just multiply it by 1.08, which is 108%. 100% meaning what you started with, plus the 8% right there. Okay, and you're gonna get the exact same answer. And so in a lot of cases, this is gonna be the preferred way to do the calculation instead of this 2-step version there. Now we kind of have an extra step hidden in there because we actually have to take 100 and add 8 to it to get 108%. But we're just, if we load that step up front, it makes a lot of other calculations way easier. All right, I am going to be quiet for a little bit while you guys group up and take a look at activity 4.1. I'll talk more about certificates of deposit later, but I hope you read through that on your own too to help get that idea in your head. What I want you to do is take a look at problem situation number 1 here for a 5-year certificate of deposit and do these calculations in part 2. Question 3, sorry, asks you to rethink how you did that calculation. And that's the whole idea of these 2 versions of the formula here, okay? So go for it. Let's see, where's that picture right there? Okay. So basically question 1 is filling out line 1 here. Question 2 is basically filling out the rest of the table. Calculator will be necessary here. So after you guys do questions 1, 2, and 3, check in with your neighbor. I'll verify your work with a spreadsheet. Daisy, let me know if you have any questions as you work on this.
Okay.
You can either text them or speak them. I've got the text box visible here. You forgot your computer. Emily forgot her computer, so she can't hook up with you today.
Yeah.
tissue, it's not sniffing at me.
Yeah. Thank you.
Tissue, see if anyone else needs them. So remember, if you whip out your calculator to do something, make sure you write down what the calculation you used your calculator to do. There's a line for that in table 2. So your first line could look like that. But it may look different depending on how you choose to do the calculation. Yep.
So why do you have 1,000? Yeah.
So order of operations. I can't do that addition there till this multiplication is done because multiplication comes first.
Right.
So here I'm calculating the amount of interest and then I'm adding it back on. Yeah, so with a certificate of deposit, if it's a yearly appreciation, then what they'll do is at the end of the year, they'll say, okay, we owe you 2% of whatever you invested. So it would be $20. So now in your account, you have $1,020 at the end of year 1.
Okay.
Then they do that, look at the end of year 2. Oh, you have $1,020 in your account. We owe you 20% interest on that, and they add it back in. And that's what this line, or 2% interest, sorry, 2%, that's what this line says right here. The amount in your account is your, whatever amount you had, plus PR is your interest amount. Yeah, so right here, we're doing this calculation right there. The interest amount is PR. So it's principal plus interest every year, principal plus interest. The key here with a certificate of deposit, instead of them sending you $20, they just stick it in your account, so your account grows. So what's year 2 gonna look like? So I put down what I think they got in 5 years, see if you can match it when you get to that line.
And once you get to 2 years, are you still adding, it would be 1,020?
Yeah, you now have 1,020 in the second year. Yeah, they just look what's in your account. The end of the second year, how much money do you have in your account?
Both of them or just the one?
You have $1,020 in your account.
Yeah.
How are they going to calculate your interest?
Do they use 1,000 or
How much is in your account?
1,000?
That's what they have to use. Yep.
So. Decimal, since it's money, do you just
Round to the nearest cent. All right, so you definitely want to start comparing with your neighbors, especially for part 3. Part 3 requires 2 things of you. You have to come up with a way to rewrite the formula that's given in question 1, and then you have to use that to redo the table, essentially. So for part 3, I'm going to have to come up with a new version of the formula and new versions of the calculations to get the same answer, which is a lot like that problem I put up on the board a minute ago for that tax, the sales tax. Instead of a 2-step equation, it's going to be a 1-step equation. Instead of 8%, you're using what? 2%. Yeah, so it's going to be just like this problem here. So this blue thing is like problem number 2 table. You're going to basically have to redo how you calculate for that table, see if you get the same answers using this 1-step version. Question number 3 says, how would you write the formula for the 1-step version based on the variables you're given here? A equals P plus PR. Okay, so check with a neighbor on that. I'm not going to intervene yet. Anyone come up with the shortcut formula instead of P plus PR? How do we look at it instead? We'd add on. Okay, so what's 100% as a number? As a regular number. What is it? It's 1. Yeah. So in our formula, it's just going to be 1 plus whatever the rate is as a decimal. So what does my formula look like? So right now, I have A equals P plus PR. We talked about this Monday or Thursday, I can't remember, but the same formula. What can I do when I have a common factor on each side of a plus? I can pull it out, right? Okay, that's called factoring. So the question is, what's left behind if I pull the P out? Nope. Not just R, because if you just put R there, then you multiply back through, you just get PR. What happened to the other P?
P over P.
What's P over P? Yeah, it's like dividing. So what's P over P? 1, it's 1 plus R. Yeah, when you factor something out, factor is like dividing. So this essentially what I did is say, okay, what's P over P? That's 1. What's PR over P? That's just R. So the new formula we're using for part 3 is that one right there. So what I want you to do is then rewrite that calculation in this manner instead of that manner. So basically your table is going to have 2 calculations in it. You can squeeze it off to the side if you want to, put it on another piece of paper if you need to. So for example, yeah, so we basically front load that right there.
Yeah.
So for us, our R is 2%. So we're going to have 1 plus 0.02. So now I'm going to take whatever the previous balance is times 1.02. And that's my new formula. So in my table, off on the side maybe, or right here, I could say I now have 1,000 times 1.02. And then in this line right here, that's the same thing as 1,020 times 1.02. What was the answer for this one right here? Is it 4040? $1,040.40?
Yes.
Okay. So what's the shortcut version for that line? Yeah, 1040 times 1.02. And I want you to write that in your table too. If that you don't have enough room there and you can't squeeze it on the edge, then on another piece of paper, make another table and rewrite it there. Okay, so I'm going to rewrite mine on another piece of paper.
How does that work out? So 1,000 times 1.02 times 10, it can work out.
Why are you multiplying by 10?
But down here it says 10 years. You're looking for after 10, 20, 40, 60, 80, and 100 years.
We'll get to that one in a minute. Yeah, we're not quite ready for that. Okay, so Robert is jumping down to this table right here. How can we skip from 10 to 20 years? We'll get there in a minute. So first, double check these calculations. And seriously, I need to see this on your paper. I need to see that along with the other calculation. 40. So if you didn't write it down now. And then we'll figure out how to do table 4. So I got the same exact numbers before. That's not the issue here. The issue is that I can write it differently. And that is super important. And if we make the right observation here, that's going to make problem 4 way easier. Okay, you figured it out? Okay, tell us about it, Cole.
What?
Tell us about it.
What do you mean?
You said it already helped you. You figured it out.
Well, you can, that's like a formula, so you can just plug in, you have to plug in time, right?
Yeah. Yeah. How do you use time here? Yeah. So how does the 5 years relate to how I got to this step right there?
You do it with the rate.
What's that?
With the rate, like you do with slope, right? The slope has the t would be like.
Ah, okay. That's a good point. So I want to show you something here. So on another sheet here, I threw this into my spreadsheet to do, and I'll show how I get those in a minute. And then I tweak the formula so I can do 10, 20, 30 without having to do 11, 12, 13, all that in between years. Okay. Now, you mentioned the idea of slope. Slope means you have a constant rate of change. So is there a straight line from the first one to the last one? Definitely not. So we don't have a constant rate of change. So we can't just multiply by time. If we just multiply by time, that would imply it's changing by the same amount of money every year, but it's not. So I put that in my table here somewhere. Oh yeah. So I calculated from 20 to 30, from 10 to 20 years, we went up by 266.95. But another 10 years from 20 to 30, that went up by 325. So my slope between every 10 years, is my slope staying the same or is it increasing? Yeah, the slope's increasing. So this isn't a line, so we can't just multiply. Something else is going on here. So back here on the table, we're doing the same thing each month. What are we doing each year? What are we doing each year that's exactly the same? We're multiplying by 1.02. Okay, so we're repeatedly multiplying. What's another way to repeatedly multiply? Exponents, yeah. So check this out. I'm just going to pick on year 2 and then year 3 and hope this makes sense. So in year 3, I had to take 1020 times 1.02. But where the heck did that 1020 come from? It came from the previous line, right? To get that 1020, I had to take 1,000 times 1.02. That right there, that represents the 1020. So then I'm taking that and I'm taking it by 1.02. So I'm just moving this right down right there. How do we move on to do year 3? So this calculation right there is year 2. In year 3, I take whatever I got in year 2, which is this mess right here before I plug it into my calculator. And I'm going to multiply by another 1.02. So mathematically, what's the shorthand for multiplying this by the same number 3 times in a row? It's an exponent, right? So this would be 1,000 times what? 1.02 to the third power. Okay, so whip out your calculators. On some calculators, you're going to have to do 1.02 to the third first and then multiply by 1,000. My hope is that you're going to get that number right there. In 1.02, raise it to the third power, and then multiply that by 1,000, and you better get roughly $1,061.21. So we have a shortcut. So we don't have to do every damn year. We can just jump right to 10 or 20 years. Okay, so somebody says, hey, I'm thinking about leaving my money in this account, my $1,000 in there for 20 years. Without doing all the years in between, how would we calculate their 20-year balance? What's that formula going to look like? How do I start it?
A equals
1,000 for this problem. Yeah, we'll generalize it in a minute. Times what? 1.02 to the 20th power. Yeah. On a spreadsheet, I would have to type it as like this way, 1,000 times 1.02, and then I have to use that caret symbol on the keyboard and then type my 20 next on the computer. So bam, I don't have to do all the years in between. And remember earlier I said we were moving on from straight lines to a curve that's called an exponential curve. It's because the exponent is varying. So exponent varies. And this leads to what's called an exponential equation. Exponential equation. So in general, how can I rewrite this using the variables a, p, r, and t? So I'll get it started for us. A equals, what comes next?
P,
Yeah, there's my p. What comes next?
R.
Not r, but one plus r. Yeah, so we got to use that increase idea. So in parentheses, 1 plus r. Where's t, the time, go? Emily, pick up. You got this.
Up above.
As the exponent right there. Yeah. So this is the exponential version of repeated interest calculations. This is called compound interest. All compound interest is repeated simple interest. Okay, you have enough information to get through problem number 7. And given the warm-up, you actually have enough information to do problem number 8. P times, that's an X there for times. Let's make that a dot instead. Mm-hmm. Yeah. So let me get that in here for everyone. And this is something that on a spreadsheet, it makes it way faster. So if you want to try a spreadsheet, if you have a computer, otherwise I'm going to go over spreadsheets next class. So there's what my first 2 lines look like in the table for number 4. Two tricks to that. How do you use your calculator to make it happen? Or how do you do it on a spreadsheet?
If the top one's 1218, there would be no sense, I think. Right? Since it was in the, it was like 1217.997.
Yeah, so I would just round up to 1218. So, that's interesting. How did I get that? I think I typed that in my spreadsheet. Where's that? I got 994. You said you got 997 on that one?
It might have been 994.
Yeah, so if it's 994, they wouldn't round up.
It doesn't round up at all. Like that 9 doesn't round up to the other 9 then?
Mm-mm.
Okay.
It would just be 99, 1899. Yeah, if that was a 997, then the bank would have the option to round it up for you to the nearest cent.
So
They don't have to. They can chop it off too. If it's 0.7 of a cent, they could just say, nah, you can't have that. And it's actually legal. There's a law called the Federal Truth in Lending Act that dictates all those kinds of calculations. All right, so we're about out of time for fun with math. I just want to go over a couple things and set you free. So on number 5, you're going to plot the points you got. So 10 years versus the account balance, 20 years versus the account balance, and so on. So you have to decide what your scale is going to be to see all those numbers for the amounts of money. So did anybody get the 100 years calculated? What did you get, like 7,000-ish? Yeah, so we got to be able to see, you know, about $1,000 all the way up through $7,000. And if you notice, there's 8 lines there, so scaling by 1,000 works pretty good. So make that on paper. In tomorrow's class, what we're going to do, where'd it go? Is we're going to do it on a spreadsheet too. So we'll do the same calculations on a spreadsheet. I'll show you how to make that happen. And then we can clearly see these points don't line up, right? So one question you're going to try and answer for part 6 is, well, okay, well, why isn't it a straight line? Right? And you're just going to try to make some kind of answer on that. And, you know, whatever you come up with is fine, but come up with some idea as to why it's not straight. And then we'll pick up from there. There's homework and prep. If you haven't done the prep, get it started. If you haven't taken a look at the homework, get that started today too. And we'll aim to finish up 4-1 tomorrow. Have a good day.